we're talking about, so to begin talking about inverse functions, they're going to start talking about whether a function is one-to-one or not. Yeah, rather than all the details, let me just give you the idea. Rather than just like, that's not very clear. Only one-to-one functions are invertible. That's the big idea of the first 15 problems, probably. Only one-to-one functions are invertible. Not all functions can be inverted. Only very special ones, very clean ones, one-to-one functions. Now, what do I mean one-to-one functions? I mean 1x for every 1y. That's what I mean by one-to-one. Each x has its own y. 1x for 1y. Never 1x for 2y's or vice versa. It's always 1 for 1. That's what we mean. So what are we talking about? Well, do you remember the vertical and horizontal line tests? Especially the vertical. Remember the vertical line test? If you have a function that looks like that, it's technically not a function because a vertical line would hit 2 points. It would fail the vertical line test. So if it fails that, it's not a function. Why is it not a function? Well, because you see this x value, whatever it is, let's just make up a number 2, and that's like maybe up 3 and down 3. So that means that's the point over 2 up 3, and that's the point over 2 down 3. See how those are the same x value of 2 going with 2 different y values? So that's not one-to-one, is it? That's why we have the vertical line test, because if a vertical line, a perfectly vertical line, ever hits 2 points, then that's the same x value, same amount over 2 at 2 different heights, 2 different y values, right? And so that's not one-to-one, that's not a function. So now we not only have that you already know. Now we're going to also bring into the mix what the horizontal line test. We're going to say, well, how about if you have something like that? By the way, you know what that is. That's like y equals x squared, huh? Mm-hmm. So now I'm telling you, we actually don't like that thing very much because that's not going to pass the horizontal line test. If you do a horizontal line, that'll hit 2 points. Now, what does that mean? At some height, like, let's just say that's 7. This is back 10 over 10, maybe. So at back 10 up 7, and at over 10 up 7, that's 2 different x's going with the same y. 2 x's at the same height. Right? So that's not one-to-one because it fails the horizontal line test. So if you fail the horizontal line test, it's still a function. It's still a function, just not one-to-one. Right? What do you mean it's still a function? Well, it passes the vertical line test. Right? That would pass the vertical line test. That's the most important one. The vertical. If you don't pass the vertical line test, you're just garbage in our eyes. That's kind of like the hierarchy of what we like and don't like. Right. If you fail the vertical line test, you're junk. We just say you're not even a function. You're not a function. That's the big one. Yeah. We don't want the same x going to 2 different y's. Right? We don't like the same input, x's are inputs, going to 2 different outputs. Imagine a toaster that wasn't a function. The same input, x is 2, goes 2 different ways. So you put the same thing in the toaster, you get different things out. Put in bread, sometimes I get out waffles. Who knows what's coming out of that thing? That would be awesome. Crazy. Maybe that'd be great, yeah, but that would certainly be weird. So we don't have that. We don't want that. So that's the big no-no is failing the vertical line test. But we also don't want you to fail the horizontal. Now, why? Why do we care about the horizontal? We mainly care about the horizontal because of what an inverse function is. Let's think about what an inverse function is, and I'll go back to that screen. Inverse. Let's be real life. Let's go to the toaster thing again. Just remember how a toaster works. You put in bread, you get out toast, obviously. Right? You put in bread, you get out toast. That's a toaster. So what would be... Oh, whoops, I shouldn't write inverse. So that's regular. So this is the regular. So the regular does that. Yeah, and then down here, I'm going to do the inverse. What would be an inverse toaster? How would an inverse toaster work?
You put in toast and get
Yeah. Yeah, well, yeah, right. You'd put in toast, you'd get out bread. You'd turn toast back into bread. That'd be the inverse, right? That'd be crazy. You wouldn't want that. But anyway, I want to make sure that the physical idea is in your mind. That's exactly right. That's exactly what we're talking about in this section 5.2. 5.2 is all about inverse functions, switching what? X's and Y's, huh? Inputs and outputs. Just like an inverse toaster switches bread and toast, that's what all the inverse functions do. There is switching of X and Y, a switching of inputs and outputs. So if you switch X and Y, domain is what? X or Y? What is domain? X. Domain is X's. Range is Y's. So if you're switching X and Y's when you make an inverse function, you're switching domains and ranges. Okay? And you're switching graphs. So now let's go back to this screen and think about what today's all about, what the second section is all about, inverse functions. If you switch X's and Y's, if you have some function like y equals x squared here, and we say, well, he's okay, he's a function, he passes the vertical line test, yes, he does, but he fails the horizontal line test, which means if you inverted him, if the original fails, like y equals x squared, the original fails the horizontal line test, then when you invert him, the inverse will fail the vertical line test, and that's trash. That means the inverse is not a function. Thus, he is not invertible. I don't know if invertible is with an I or an A. Anyway, he's not invertible. Get it? So if you fail the horizontal line test, your inverse, because everything switches, will fail the vertical line test. And your inverse won't be a function, therefore. So you're not invertible. So that's why we especially like functions that are one-to-one, because only those are invertible. Only if it's 1x for 1y, it's going to pass both the horizontal and the vertical line test, then it's invertible. So what would do that? That'd be something like the snake. We like the snake. Y equals x cubed, right? He passes all the tests. Every horizontal line hits only 1 point. Every vertical line hits only 1 point. He is a one-to-one function. So he's invertible. He is invertible. He can be inverted. I want to write that with an A now. Is it with an A? I don't know. All right, whatever. I'll do it both ways. Then I'm for sure wrong somewhere. All right, so it's invertible. Maybe it isn't I. It's bugging me now. All right, anyway. So he would be invertible. He would be invertible. Right? And think about him for a minute. Any x you put, well, think about why is x squared not invertible? Because you could put in -2 and you'd get 4, and you could put in +2 and you'd get 4. See, that's the same x going with two different y's. He's not one-to-one. So x squared is not one-to-one, and he's thus not invertible. But x cubed is. Okay, so that's what the section's all about. We want one-to-one functions because only those will be invertible. Both their original and their inverse will be one-to-one. They'll pass both the horizontal and the vertical line tests. All right, let's get to the homework then. So with all that in mind, hopefully we can move fast over the first 10 questions. So number 1 here is that thing one-to-one? Yes. Yeah. It's just one thing here goes to one thing there, one to here to one. What would not, that one's yes. What would not be invertible? Well, if you had a couple things, you had like 2 things going to one thing. That would not be invertible, right? So this one's good. How about this? Was this one good? Yeah. Yeah, it's all good. Those are good. Good? Next. Let me show you. So I'm just going to make an XY table, right? Because this is X, Y, X, Y, right? So 2, 9, 3, 9, etc. Already we have a problem. Yeah. Not. It's no. They're going to the same Y. It's not 1 for 1, is it? Good? So you'll fly over these first 10 questions, I think. That'll be super. So what do you think? Is this one? Is every horizontal line hits only 1 point, so he's good. This one, no way. Horizontal line hits 2 points, no. Good? So, okay. So here's a function between players and how they did in the game. Amy got 160 points. Lynn got 150 points, etc. That's a function. This is the domain, right? It's the x's. This is the range. This is the x's. This is the y's. But then they're going to say, find the inverse. So what's the inverse? Swap x and y, huh? This one's the inverse. If you look over, they messed up this one. So this is the inverse right here. So this is the domain of the inverse. So notice domains and ranges swap, don't they? And this is the range. This is the inverse function here. I'm going to move on. I think. How do you find the inverse? This is x, y, x, y. You just swap them, huh? 11 minus. See how I just swapped them? Just swap x and y. Swap the next pair. Swap the next pair, etc. Is that good? Just switch x and y, switch x and y, switch x and y, switch x and y. That's what an inverse function is. Excuse me. Switching of x and y. Problem. They're going to say find f of g of x. Guess what's going to happen? We're going to grab g and put it into f. Those guys are inverse functions. Do they just look like inverse to you? They are. Do you see that they're inverse? Because this one is multiplying by -2. This one's multiplying by -1/2. That's the opposite. This one's subtracting 4. This one's adding 4. Yeah, it's going to come out x. Exactly. Let's do it. So it's going to be -2 times something minus 4, and the something plugged in is -1/2 x plus 4. So I just put g into f. Do you see that? And you see what's going to happen there? How are we doing? Am I rushing so fast you can't even write this stuff down? Okay, it'll be on YouTube. I just wanted to get to those hard ones. Number 19's calling to me. So these cancel, huh? 2 negatives make positive. Half of 2 is 1. So it's just x plus 4 minus 4. It's just x. Remember, that means they're inverses, huh? When you take x and you run through both functions and it comes out the way it started, those are inverses. That means this and this are inverse. So it's more of that. So I'm just trying to save you time here. See what I wrote for 5-2? 12, 13, and 14, the answer is always x on 5-2.
Oh, wow.
12, 13, they're just doing 3 in a row, inverse. And now, 12 wasn't long. That wasn't bad, but look at 14. Okay, so yeah, take a look at it here. So, yeah, they're saying, there it is, take this and put it in there and put it in there. I don't want to do all that. X, it's going to come out x. Those are more tricky. Those might not look like inverses, but they are. That'll come out x. But you're going to have to do the domain stuff, though. Yeah, you will have to do that. Sorry.
You do it, you go by it before you clean it up.
Yeah, do the domain before the cleanup. So I'm going to move on. So 12, 13, 14. So remember, 12, 13, 14. The answers are always x, and then you got to do the domain stuff. Okay, so this is number 15. So you're going to say, hey, what happens graphically for an inverse function? What does it look like? Well, we can figure it out. I'll tell you in advance. It's going to be the reflection across the diagonal line. That's why that line's up there. Let's see it. How do I form an inverse function? This is x, y point. So if I swap them and get 0, -4, that'll be a point on the inverse function, won't it? Remember, that's what an inverse function is an inverting, a switching of x and y. So if I find the point 0, -4, over 0, down 4 right there, there's the point over 0. So this point goes there on the inverse function. Let's try another one. How about 1, 2? Where does he go to? 2, 1. Where's that? Over 2, up 1 right there. Over 2, up 1. That point goes right there with the inverse. What about 4, 5? He goes to 5, 4. Where's that? 1, 2, 3, 4, 5. 1, 2, 3, 4 right there. Over 5, up 4. So you see what I did there? I just swapped the x's and the y's. Oh, and then there's this one down here. -5, -5. You swap them. It's still -5, -5, huh? So, all right. Now, let's connect the dots of the inverse function. See what we get? It reflects across the diagonal line. So this is the inverse function here. And this is the regular function there. So a function and his inverse are mirrors across the diagonal y equals x line y. Because that's the line where y values equal x values. So if you're swapping x and y, which is what we're doing for an inverse function, you'll jump across that line, same distance other side. Is what you'll do. You'll jump across the equality line. All right.
Yeah, take it.
So x cubed minus 2. So number 19, f of x equals x, or I'll just call it y. Y equals x cubed minus 2. They're going to ask me to find the inverse. So these last, I only have 5 or 6 problems, but I don't have time for like 2 or 3 of them. It's going to all be about finding the inverse. These are some of the messiest ones.
Root 3 plus 2.
So, okay, so, yeah, you could guess at it. The main trouble you're going to have with guessing is it is root 3 because rooting's the opposite of power. Is it that way or is it that way? That would be the only thing that might trick you. It's actually this one. Because it's not only the opposite operation, but it's the opposite operation in the opposite order. See how this subtracts 2 last? Then you got to add 2 first inside. Anyway, it's hard to do all that, so I'm going to give you a process that's easier than guessing around like that. So here's the steps for finding an inverse function. Step 1, switch, invert, x and y. Right? Because that's what an inverse function is, huh? It's a switching of x's and y's. So let's do that first off. So step 1, this y becomes x, and this x becomes y. We good so far? So you literally switch x and y. And then step 2, solve for y. Just get y alone. Just switch x and y, solve for y. So now we'll come down here to step 2, and we'll solve for y. So I'll give you a second. Can you get y alone there? Can you solve for y? So I'm going to add 2, or I'm just going to grab that -2 and jump it, right? Same thing as adding 2 to both sides. And then how do you turn that into just like normal y? Cube root's opposite of third power. Yeah, sure. So there it is. Cube root of x plus 2. That's the inverse function. Good. So how do you find an inverse function? Switch x and y, solve for y. That one's not bad. They're going to get a little messier. So switch it. Oh, actually, they ask you a couple other things. That's right. I got it. So this is the inverse function, and this is the original function, right? If y'all got that, I'm going to go to a fresh screen and write, okay, original function is x cubed. Was it minus 2? Yeah. And the inverse is that, okay. And the inverse over here, the inverse function is cube root of x plus 2. Now, they're going to ask me for the domain and the range for both of these, which is easy. Let me show you. So they want the domain for both, and they want the range for both. So how do we do that? So you know about domain. You guys are pros at domain now. We've done a lot of domain. How do we find the domain of this function?
It's all real.
All reals, because he doesn't have any, no roots, no denominators, no problems, right? Is that good there? So he's all reals.
Cannot be negative. So it must be greater than.
So let's go to the other side now. Now the inverse, let's do his domain. So what's the domain of the inverse function? What's that? All real numbers again. Remember, we talked about half an hour ago, odd roots are not a problem. This is the one I was getting ready for. Odd roots are not a problem. Remember, odd roots, no problem. So this is all reals. If that was a square root, a 2 root, then I would have to do the inside greater than or equal to 0, not negative, and solve it, right? Everybody good with that difference? Remember that? We talked about that half an hour ago. Okay, now, how am I going to get the range for these guys? Remember, an inverse function is what? It's an inverting of x's and y's, inputs and outputs, domains and ranges, right? So the domain of the original function, all reals, goes where? It's the range of the inverse. And the domain of the inverse is the range. Now this one's kind of silly because it's all reals, but they'll be different in a minute. Is that making sense? They just swap. So you just find the domain for both, and those swap and become the range for the opposite. Because that's what inverse functions are, swapping of domains and ranges, x's and y's. Is that good? I want to move on. There's some much messier ones. Oh, last thing, they're going to make you graph these. Do you remember at all how to graph them? We've graphed them both. Let me do that real quick. F of x equals. It's kind of nice to see it on the graph. It is interesting. We've got a lot of truth now, and we start to see how it all fits together really perfectly. It's kind of nice.
That's the snake shape moved over to the right.
Okay, so yeah, what they're going to ask you to do is graph both of these on the same axis. So let's graph the red one first off. Remember, we learned to graph that it's a snake? And what's that minus 2 do?
Moves it over to the right.
Or not up, down. Down 2. That's a y effector. That's not in the x. That's going to go down 2, put a dot there, and make a snake, right? Good? Now, what about the black one? What's cube root?
Forward.
A sideways snake.
Oh.
Remember, it turns the snake sideways. It's one of our original 6. Turns the snake sideways. What's that plus 2 in the root going to do?
Move it over.
Yeah, left 2, because it's an x effector. It's in x's world. Whereas this 2 was a y effector. Minus 2, it was out of x's world, huh? This is an x effector, always opposite. Plus is left. So left 2, put a dot, put a sideways snake. Do you see how that's a perfect reflection across the diagonal line? See that? All the truth we're learning is really truth. It all fits together perfectly. How we graph these things, how we move these things, how we find an inverse function, and how inverse function graphs reflect. All of those are singing, I can't sing, but there we go, in harmony, perfectly the same tune. Right? It's all nice. Okay, same thing. They say find the inverse. I want to specifically, this is the main one I wanted to get to, because this is an important one, this is a hard one, and it comes up a lot in calculus. This is for sure one that I'll give you on the next exam. There's like 3, I think there's 3, maybe 4, that are just like this, where you have to do a certain thing, which I'll explain to you in a second, which is really important in calculus. You do it all the time in calculus, so it's like for sure, you can make a note to yourself, for sure one like this is on exam number 2 in 2 weeks.
Automatically, I'm thinking, why isn't the inverse going to be the same thing as the reciprocal?
That's a good question. Yeah, inverses are not the same as reciprocals. That's a different kind of thing.
Right.
I don't know how I would prove it. Well, we'll see when we're done here.
Okay.
It won't. It's not. And it wasn't the same back here. How about that? If what would be the reciprocal of that? 1 over the whole thing. That wasn't the inverse, huh? Yeah. So reciprocals are not the same as inverses. They're just different. So all right. So how do we find the inverse? What are the steps? Step 1. Yeah. Switch x and y. Now where is y? I don't see y. Yeah, the function is y. So there's my y. So that's going to become x, and both those x's become y's. Everything else stays put, huh? Nothing else moves. Just x's become y's, y's become x's. That's exactly what it means to find an inverse. X's and y's trade roles. They don't trade positions. Nothing else moves. They just trade roles. Okay, and then step 2. Step 2 is, what's step 2 in finding an inverse function? Solve for y. Get y on you. This is the part that gets a little tricky. So yeah, so let's start there. Let's put this over 1, go diagonal, diagonal, right? We've done this kind of thing a few times. And x times 9y minus 5 is 1 times 2y plus 8. Good so far. And then distribute, right? I think it's exactly what you'd expect. So 9xy minus 5x, distribute, 2y plus 8. Now, I'm trying to solve, so this is right here, this is the moment I was wanting to get to. Right here is where it can get a little tricky. We're trying to solve for y, aren't we? Y. And notice y is in two places with other letters involved. That comes up a lot. Let me write you a specific set of steps. When you have a letter you're looking for in two places, this happens a lot in calculus. Step 1, get, well, let's just call it y. The y in two places. I don't want to refer to letter every time. The y is in two places. Get the y's on the same side. So step number 1 is you got to get those y terms on the same side. So that means I'm going to grab this 2y term and jump it to the left, and I'm going to grab the minus 5x and jump it to the right. I want to get all the y stuff on one side, the non-y stuff on the other. And what happens when something jumps over the equal sign? The sign in front switches, doesn't it? So this is going to become 9xy minus 2y and 5x plus 8. That negative 5x became positive, huh? Good so far? See how I've got both y's on the left now, and the other side has no y's at all. So when I get all the y's on one side, the other side has no y's. That's step 1. Now, remember, I'm trying to get y alone, huh? Can you think?
Factor it out.
Exactly. Factor it out.
And divide by 9x.
And divide. Factor out the y
We do it
and
chemistry all the time.
divide. So factor out the y.
Like when we do the algebra before we come up.
See how that gets it isolated? And then divide by what's next to it, the 9x minus 2.
I like the algebra in chemistry.
Does that make sense? There it is. There is the inverse function. I have time to do one more of these, I think.
I'm not going to.
So did you all track with me on that? So when the y, so this is what I'm saying will for sure be on the exam in 2 weeks. It'll be something where you have the y in two places, get them on the same side, factor out the y, and divide. That is the inverse function.
Yay.
Questions on that one? We'll try one more of those with the time we have. No questions? Y'all got that one down? Same thing, find the inverse.
Oh, yeah. Make it x.
Find the inverse. So you know the deal. Step 1, switch x and y.
5 y. Okay. Now put x put 1.
So step 1, switch x and y. Like that. So x's become y's and y's become x's. And then solve for y. Okay, so I'm going to dive in there. So you put this over 1. So step 2 is solve for y, diagonal, diagonal. So we get x times 5 y squared is 1 times y squared minus 1. Okay, so distribute that's 5x y squared. And distribute here y squared minus 1. So what do we do now to solve for y?
I guess get the y on there.
Get the y's on the same side. So I'm going to just jump this guy over here, huh? So I get 5x y squared minus y squared is negative 1. Good so far? And then I'm going to factor out, huh?
Okay, yeah. Y squared.
Does that make sense? Factor out the y squared in this case,
Divide by 5.
and then divide by that whole chunk, right? Divide by 5x minus 1. Boom. So bring that up there. So y squared is minus 1 over 5x minus 1. Last step to get y alone. Root. Cancels. Y equals the square root of minus 1 over 5x minus 1. That's the inverse function.
We are not gonna write like plus, minus.
I knew somebody would ask. It's a great question. Yeah, do you notice I tried to sneak one by you there, Abdul, and you're on it. Why didn't I write plus or minus there? Remember my whole roof on the house up and down the ladder? Don't you have to put plus or minus when you do root? Yeah, technically. If you look back at the question, see that what they said right here? X is greater than 0.
It's gotta be positive.
X is greater than 0. What it is, this is not technically an invertible function, so they're limiting it. Say, I just don't have time to explain the whole thing. They're limiting it. Let me keep it simple like this. If in the original they said x is greater than 0, the original function, then in the inverse, whatever you say about x in the original applies to y in the inverse. So if in the original they said x is greater than 0, then that means in the inverse here, y is greater than 0. Y is only positive. That's why we don't put the minus. It's only the plus. Yeah, they had to do that for that reason, because they didn't want the two options. It wouldn't have been a function, therefore. So there's the inverse. They want you to find the domain on that stuff. I just don't have time.